Greetings and welcome once again to my new calculus channel. My name is Geogebra. So in a past video, this video here, I was wondering why it had so few views. And so I conducted a little survey and I asked for people to give me a thumbs up or a thumbs down. And I found out that a couple of very smart people I know, well, one very smart person I know, brought it to my attention that there were some mistakes. That's why it had so few views. So now I've set out to fix those mistakes. And here I am about to fix this video here, these mistakes, and I will place a link to the new video. The new video is this one. So what is the goal here? The goal here is to show that we can produce a rod whose length must be the product of root 2 and phi, which is what is realized from the attempted measure of the golden ratio using any physical unit. Now remember, this is done entirely without numbers, and that's what I'm about to show you now. So the first step, my friends, is to choose a unit, and it doesn't matter what unit you choose. It can be any unit you like. Let's just stick for one for the time being, okay? Then you need to construct the symptoms of the triangles from which you realize square root 2 and square root 5, okay? So these are the triangles from which you realize square root 2 and square root 5, okay? And it doesn't matter how big the unit is, these are always square root 2 and square root 5. Don't worry about that value there because you'd have to divide it by the unit to get square root 5. But if you divide this by 2, which is a unit length, you will get square root 5. So it doesn't matter what the unit is, okay? But I'm going to stick with the unit 1 for the time being. I'll show you again later that it doesn't matter what the unit is. So we have square root 2 realized from constructing a right angle isosceles triangle with equal sides, and square root 5 from constructing a right angle triangle with one unit and its double by simply concatenating the unit to itself. In other words, taking this unit and concatenating it to itself to get this triangle side. Next, we construct the circle unit because I'm going to use a circle to show you how to find the product. You could also use my special method, as I'll put a link into that video, but it's much easier in this case just to use a circle. Then you can construct phi and the circle phi. So how do you construct phi? Well, phi happens to be this length plus this unit length, okay, measured by this triangle side. Okay, now listen, there is no way you can take this triangle side and measure the antecedent, which is this whole side here. Okay, so in other words, the only way you can do it to measure it is to actually geometrically divide it into 2. And that's 1, 2. Okay, 1, 2. You can only do it geometrically because this ratio here doesn't have quotientness. Euclid Book 5, Definition 3. This ratio phi does not have quotientness. In other words, you cannot measure this whole antecedent with 2. And what you get in algebra, this algebraic value, is an approximation. Okay, that's all it is. It is an approximation. And so I've added the approximation down here in my circle, okay, where I'm moving it around. It's not a circle yet, but it will be. The next thing I've got to do is add my construction of root 2 to this part of the circle, right? And now, to find the product, all I have to do is draw a circle around these 3 points, which is very easy geometrically, and boom, I have the product of phi and root 2 in algebra. Now remember, this part here is algebraic, this part here is geometric, okay? And we get this value here from trying to measure this antecedent part of this ratio with its consequent 2. It doesn't matter which one you get. Notice this will always be 2.28825. Doesn't matter what unit you use. It doesn't matter what unit you use, as long as you use the geometric ratio And in algebra, you take the hypotenuse plus the unit and divide it by this triangle side, which is the unit you're using. And it can be anything, okay? Doesn't matter what it is, right? Just can't be 0, of course, because then you'll have nothing. So that is how you find the product of root 2 and phi given a physical unit. And I hope I've done everything right this time, but I'm sure my dear friend will correct me if I haven't. I'm John Gabriel, and this is a new calculus channel. Before I sign off, hit that like button, become a subscriber, tell your friends about this, and I'll put a download link to this applet so you can play with it and see that everything I'm telling you is true. And by the way, you can do all the 4 arithmetic operations with ratios to 100% accuracy without using any numbers at all. I'll put links to a free ebook and to whatever else I can think of. Till next time, I'm John Gabriel. This is the New Calculus channel. Goodbye.